Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video is going to be a continuation of my 15-piece slide puzzle video. And because I've gotten a lot of requests from students and people around the world, how do I do a win condition for this puzzle? Of course, in a real life situation, you wouldn't have that in front of you. You would just play the game. But as a computer program, we can totally look at the situation of the game board and go, hey, that's a winning condition. And so if you want to follow along and just watch what I'm doing, of course, just watch the video. But if you need to, please go back to my previous video. It's 20 or 25 minutes long. It shows you exactly how to set up the 15-piece slide puzzle to get to where we're starting from now. So what am I talking about? I'm talking about something like this. Here is my 15-piece slide puzzle. I can click and move things up, down, left, and right just to prove it. And the whole point of this lecture, this hopefully short lecture, would be, well, what happens if I spend a little time and I click, 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 and I click, 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 and I click, and you go, hey, look at that. I set up a win condition where if I get blank 1, 2, 3, 5, 6, 7, 4, 9, 10, 11, 8, and 13, 14, 15, 12, it's considered a win condition, and it screams out at me and it yells complete. And any other condition doesn't work. Notice and it maintains it on an individual basis for every individual puzzle, because it's like this one is separate from the others, right? And this one is separate from the others, and so forth and so on. And again, that just comes back to the way we set everything up. We made everything so generic and generalized in the previous video. And that's, at the end of the day, that's what we'd love to be able to do as programmers, is to make everything general so that if designers or anyone else comes around and wants to change things around, it doesn't ruin my entire workflow and my entire life trying to get my work to match what they want. And so at the moment, all you should have is a create event for this border object. You should have just the create event with this kind of code in here that sets up using the border, and then it creates the 16 tiles. Because in my room itself, all I have are two objects, one border and one border. And when the game starts up, when the room starts up, each border will create each of the 15 pieces that are associated with it, and everything again works perfectly fine because everything is tied to that specific border and this specific puzzle that's being built. We just showed it so you understand what I'm talking about. And of course the tile only has a left pressed and a draw event, and again we've already discussed all this stuff, but to you the border has this. And basically what I'm going to kind of do is rework this because I've already done the code for it, and just change it around enough so that I can take and figure out what is the current state of that individual puzzle and see if it matches up against what I want it to be to hit the winning condition. And so here's the create event, and now all I did is go over here and this is the draw event, and this is all I added. This is all this code here. I'll discuss this in a couple minutes here as we go on, but this is all I've added to what I've previously had. And so, it follows pretty logically. This is the condition, this is an array, a one-dimensional array that I've made look like a two-dimensional array, and this is aspirations. This is what the winning condition should look like. Like I said, there should be a blank. No one is just my way of using GameMaker, so because I think it's -4, some value that you can use. But I have no one, which is an empty space. I have 1, 2, 3, 5, 6, 7, 4, 9, 10, 11, 8, 13, 14, 15, 12. This is what I would like the puzzle to look like on the screen when I scream out, hey, this puzzle is solved. And we need that starting out. And again, once you have this working, you can change this thing up to your heart's content, but I just wanted to keep this simple and just contain this inside one event, and I have so far, this is the draw event. This will not work in anything else but the draw event, at least the way it is now. So here is the winning condition I want. Here is this, basically I have to figure out what is the current condition. It's not as easy as you might imagine, because we've dynamically generated objects and so forth and so on. So I'm starting out with it being completely empty. I'm just going to say, okay, right now there's nothing in here, and I'm going to use the for loops. Notice again, this looks kind of similar to what I did before, and I'm going to take that code and I'm going to fill in the array with the current values for the spaces. And so I'm saying, okay, I'm going to test 4 by 4, so I'm going to be testing 16 grid spaces to see if there's something there. And so, I'm using the same math that I did earlier to the create event to put the pieces down, I'm using the same math. I'm using a collision point event so that I can go ahead and test basically a point inside of each of the 16 squares to see if there's a tile there. Go, go to XY, which is basically the upper left-hand corner of the grid. Check to see if there's a tile there. And don't worry about the falseness. Just don't worry about all this extra stuff. But this is saying go to the upper left-hand corner and tell me, is there a tile? And if there is one, then, because that's the way collision point works, if collision point finds an object inside of that, or basically at that point, it will return an object ID. But if it can't find anything, it'll return the no one ID, which is the -4 value. So I just have to make sure, because if I don't put this if check around here, that blank square will crash our game. So when I do this, I say, okay, if the instance is not no one, meaning if there is an actual tile there, get me the tile's value and put that thing into this array, into that first space. So in our case, the 1 would go and fill in where the no one is. So then also once I do that, I check to see that value that came in, is it supposed to be the value I'm looking for? And actually, if I do this, I might not even need the array. So just to say, let's just get this working, and then I'll come back and see if we can even eliminate this current condition array and see if we can get it working. But then I'm saying, okay, that current condition, this value that I found, is it equal to the winning condition that I'm looking for? Like in this case, no one. And if it's 1 and that's a no one, you go, nope. So then I could say the game has not been won. And so the game is not complete. So I take this completeness and I've completely changed it around. And now nothing can turn it back because I found a counterexample. The game has not been won. And so then I go ahead and I go, okay, let's increase the value because I'm checking for the 0 case. Now I'm going to check the 1 case. I'm going to move over 1 square. I'm going to basically use all the math, move over 1 tile, move over 1 tile horizontally but not vertically, and check again. And so I'm going left to right, top to bottom through these two loops, checking to see what's at these positions in space, what are the values of the actual tiles, because like the number value that's being printed out for that thing, and if at any point I find out that they're not the same, then the entire thing is false. And so the cool part about this is if I go through all 16 squares and I don't find a counterexample, then I have to conclude that what I've done is correct and this is a winning condition. Because I didn't find, so basically if everything in all the squares match up to what I see here, then I have a winning condition. And that's what I have down here. I draw self, so it draws the actual border. And then if I need to, if the game has been won, I go ahead and I print out complete. And that's what's exactly happening here. So let me zoom this up here so we can see. Here is the game itself. And so no one, 1, 2, 3, 4, and so forth and so on. So any other condition but this. And that means this is a winner because this is no one, 1, 2, 3. And you can see that all the other numbers match up, but any other condition does not. So I think this is a pretty cool, simple solution. It's nice if you just came off the previous video, you already kind of have this going on in your head, the logic of what this is trying to accomplish and how it's trying to accomplish it. But that is it. That is essentially the entire thing. I can change this around. Let's see. Let's put it back and just say I want 1, 2, 3, 4. Oops, this is the fun of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I say 13, 14, no one, and 15. We'll try that one out instead. And so now I go back and I go do this stuff, and it goes, nope. A minute ago that was perfectly legitimate and that was a winning condition, but not anymore. And now all I have to do is click here and there we go. I am now complete because that matches up with what I'm doing. So you just have to make sure that you put the correct values inside of here such that you don't duplicate values and you can actually hit the winning condition. You have to test for this. There are certain ways, depending on the way this starts out, 1 through 15, there are certain combinations of numbers that you can never reach And as hard as that is to believe, there are ways that you can find unwinning conditions, and so you have to watch out for that. But that is pretty much the entire code. Here's what I want to aspire for a state to win. Here, all this code gets me to that, fills this thing in with correct values for what's in the current state, and we're just checking one by one to see if everything matches up. Okay, so now I've kind of said this. I think I can get rid of this and simplify this code a little bit more than even what we see here. And I can say, oops, I had value already. And I'll call it tile value is equal to no one. And if ints is equal to no one, then tile value is equal to this. So I don't think we don't even need the second array. I think this just goes ahead and does this all. I thought about restarting the video, but I like showing you guys that there is always room for improvement. You get something working, you're happy with it, and then at the end of the day you go, my goodness, I can increase the efficiency of this thing, and especially with this, I don't need an array. So let's see, I do this, do that, and there you go. It works, just like it did a minute ago, but I'm not wasting my time with that array. Okay, so what have I got going here? Here's my winning condition, and now all I've done is basically replace, because I'm only looking one tile at a time, and I don't need to maintain all those tiles, because I don't care. I either won or I lost. It's a complete Boolean thing. I don't care how many tiles are not in place or anything like that. If you care, then go back to the previous version of this and fix that up. But if you just care yes or no, did I win? This simplifies things greatly, because I say, okay, start out with a no one value and then fill it in if you can. Maybe you can, maybe you can't, because maybe there's an empty square there. But at the end of the day, if that value, whatever the tile value ends up being, is equal to the tile I'm searching for right now, or if it's not, then we haven't won the game. And I'm tempted to put a break in here, but it's a doubly nested loop, so you'd have to break twice. And that's why I don't have a break for those of you who are like, why don't you have a break? Because it's just more complicated. And it doesn't make much sense for this game. We're not worried about efficiency when it comes to speed. This game is not testing anything when it comes to the boundaries of computer technology trying to work. So coming back, here's my winning condition one last time. So I'm starting with this and moving around and figuring out spaces, checking to see if a specific tile in space matches what I want it to be, and then basically coming down here and testing everything out and go, if it is complete, if we've won the game, then tell me so, otherwise don't tell me anything at all. So you could even have an else here if you chose to, and just say, keep trying or something, and being, you could be mean, you could be nice, you could be whatever it is you want to be. So let's see, can I get this all on one? I don't know if you'll be able to see it even if I can get it on one page. There we go. That's fun, right? Let's see, make it a little bigger. There we go. One more time, nope. So there you go. That's all the code I added to this, and this is in a draw event for the border object, and everything else will work just spiffy and everything great. So, as always, if you have questions, please comment me, send me an email, swardb@cod.edu. I will get back to you as quick as I can. I don't always check YouTube, so email is a better way to get a hold of me these days, especially now that the semester has started up. And if you have any other ideas, I'm always, this video was made because you guys wanted to see it. So, if there's anything more, please, I'll put it on my list of things to do. I got a ton of videos to make this semester for my students in 2 different gaming classes, my 2D scripting and my 2D game development, and I will do what I can. My entire semester, the only videos I have to sit down and make are these videos, and these are the most fun to make. So I'm glad I could help you guys out today. Take it easy, everyone. We'll see you next time.